Hey everybody, welcome back. This is problem 2 in the last homework assignment. In the first example, we use a TI-84 to conduct a two-sample z-test. We knew the population deviations for each group, and we were told that they were normally distributed. In this problem number 2, we will not know the population deviations, but that's good. That expands our knowledge base. So let's jump right into it. Group 1, we have a random sample of 10 regions in New England, and they gave the following violent crime rates per million population. The second group is the Rocky Mountain crime rate, and that's the violent crime rates per million of population, and they sampled 12 regions in the Rocky Mountain states. This problem does give us the SALT. We could use a TI-84. And of course, in the class, if you want to stick with the TI-84, that's fine. You would actually pick a two-sample t-test for this one instead of z-test, but you would have to enter the New England crime rates in your L1, your Rocky Mountain crime rates in the L2 before you did all that. And then when you go to two-sample t-test, instead of highlighting stats, you would highlight data and tell it to read L1 and L2, and you can go forward with that. If that comes up during your class or while you're working on homework, of course, shoot me an email. I'll be happy to record an extra video. If there's not a good one you can find already on YouTube, just let me know. I don't mind at all. All right, we're going to jump right into this one. What we're going to eventually compare is down here in Part B. We're going to look at these two groups of data and try to make a decision about the difference in crime rate with the claim that the crime rate in the Rocky Mountain states is higher than in the New England states or region. And we're going to use a 0.01 significance level. Since this one asks for SALT, and you're going to want to make sure you've got pen and paper handy, when you go use SALT, it will come up on the next tab. You will have your data pre-populated, but it does not give you the average or the deviations. Like in here, none of that's ever given in your problem. And number one, it was given, but that's okay. While your data is populated, go over here to Descriptive Stats, click that. In this summary table, New England crime rate, that was group 1. Rocky Mountain crime rates, that's group 2. Now you're going to want to write this down, like pretend you write a number 1, a number 2, and for each one you want to write down the mean, standard deviation, and sample size. So I've written down on my notebook NE, and then under the mean I've got the 3.49 and 3.85 written. For S sub 1, S sub 2, that's going to be these two values respectively, and N1 and N2 are these two values respectively. Now the reason we have to make a quick pit stop in descriptive stats is for each group we need mean, standard deviation, and sample size. Once you've got that, and you've got it written down, then go to Inferential Statistics. We're comparing two groups, but we don't know the deviations for the population. So two sample T. Okay, now this is where you go to the information you've written down. For New England, which is sample variable number 1, we had a mean of 3.49. Whoops. A sample standard deviation of 0.8157. And there were 10 in the New England region states. There were 10 states reporting data. Sample variable 2 is the Rocky Mountain region. That has a mean of 3.85, a sample standard deviation of 0.9249, and its sample size was 12. In our hypothesis test, Your null hypothesis is always the claim that there's no difference. So we're going to stick with that. Excuse me. There's no difference in crime rates between the regions. The alternative, that's your research question. Now, because we were asked, and I'm going to toggle back, for the claim that Rocky Mountains is higher than New England, that means 1 is less than 2, because Rocky Mountains was group 2. And you have to look at it that way as group 1 versus group 2. Even though the problem says more than or greater, higher, it's group 2 being greater than group 1. So if you were to think of it the other way, New England is less than Rocky Mountains. Our standard deviations are fairly close. I'm going to leave this unchecked. Just, it says leave unchecked if you're unsure. It's probably safer just to not check it. Okay, so group 1 is New England, group 2 is Rocky Mountains, group 1 less than group 2. Let's generate the results. Up here, these two, not that one, we're going to need to write down that value. Our t-stat is negative 0.9697. I'm going to write that down. Our p-value is 0.1719. Okay, once you've got all that written down, and our values down here at the bottom are the descriptive stats again, I'm going to go back to our problem. Okay, so this is from where I told you to write all that stuff down. X1, that's the New England mean, 3.49. Excuse me, y'all. I don't know why the tab button's not working properly on my computer. Anyway, standard deviation for the New England, that's the 0.8157. And my dog only is thirsty during the videos. Rocky Mountain average was 3.85. And standard deviation is 0.9249. Significance level is given, 0.01. Okay, be careful selecting your hypotheses. Initially, your null hypothesis, you want to go equal. Group 1 is the same as group 2. There's no difference. So that eliminates the third choice. If we're claiming the Rocky Mountains has a higher crime rate than New England, then group 1 is smaller than group 2. I'm going to pick this set of hypotheses. We're going to use a student's T. We're going to assume that the groups are normally distributed, but we don't know standard deviation of the population. That's unknown. Okay, our T value that we wrote down is negative 0.9697. 9697. Now let me type it out. They're asking us to round to 3 decimal places. So the 7 is going to make the 9 a 10. I guess 70. 0.9697 would, to 3 decimal places, the 9 would become a 10, so 0.970. Don't forget the negative. Our p-value was 0.1719. 0.1719. That would be this second category. Okay. Now, since we picked less than, we only need shading to the left. Our t-value was a negative, I get off of there, 0.970. So this bottom left graph matches our t-value and shading to the left. Our p-value is greater than alpha. P is 0.1719. Alpha was only 0.01. So if p is greater than alpha, You fail to reject, you don't have significant data. At 0.01 level, we fail to reject the null hypothesis and conclude the data are not statistically significant. By failing to reject the null, you do not have enough evidence to suggest that the crime in Rocky Mountain region is higher than the crime in the New England region. It may very well be, but the two samples that you have aren't enough evidence to make that claim. I'm going to submit. We'll check our answers. And let's see, number 2. As long as it lights up with green check marks, that's a good day at the office. And they have. Okay. I'm going to conclude this video, and then before we do number 3, I'm going to make a third separate video because it's based on proportions, 2 proportions. But anyway, I'm going to shut this one off. This is number 2, using salt. Using salt. It can be done on the graphing calculator. You will just do L1, L2, and pull up 2 sample t-tests.